Okay, so now we're going to talk about section 4 in our chapter, which is on star systems. So talk a bit about galaxies and things like that as well. But first thing is star systems. Most of them are going to be members of groups of 2 or more stars called star systems. Ours is obviously a single star system. We have a bunch of planets that go around, and other things, obviously, that go around one star. But a lot of times they'll be part of more than one star in a system. So these star systems can either be binary stars, which means they have 2 stars, eclipsing binaries, or star clusters, which are a large group of stars together. The picture down here is a picture of an eclipsing binary. So basically there's a bright star and a dim star, and they're kind of moving around each other. So anyway, the companion star itself is going to be the dimmer one, which is moving around the brighter one. Probably has a little bit bigger gravitational pull to it. And so you can kind of only see the brighter star at certain points because that dimmer star might go in front of it. And that's what we call an eclipsing binary, because eclipsing means that it's like basically going in front of it, blocking some of the light from it, just like if we have like a solar eclipse or a lunar eclipse, we block light to the moon or the sun, or from the sun or to the moon. And that's what causes an eclipse. Same thing with if there's a star system with 2 stars, one being brighter than the other going around the brighter one, which might block it out occasionally. But most of them are going to be binary stars, which are 2 stars together, or you might even have what we call star clusters, which are a large group of stars that are together. There's a couple different types of clusters. Okay, so this is what I was talking about as far as clusters go. There's 2 different types. There's going to be the globular clusters, and then there's going to be the open clusters. So globular clusters, it's a glob. It's basically a glob of stars that are kind of all hanging out together. They're all about the same age, all about the same distance from Earth. So they just look like a big glob of stars that are hanging out together. And then, of course, there's going to be the open clusters, which right here, this is an open cluster. And basically these are going to be different age of stars, different brightness of stars, and so it's just kind of more open look to the cluster itself. They're not quite as like bunched together. They're not all the same age. They're differing brightness and things like that as well. Okay, so star systems are, we're going to find that a bunch of star systems hang out together in what we call galaxies. So there's 3 different types of galaxies. There's the spiral galaxies. We live in a spiral galaxy. The Milky Way is a spiral galaxy. There are elliptical galaxies, and there's irregular galaxies. A quasar is also a different type of galaxy, but it's a young galaxy with a black hole in the middle. So that means that we're developing new stars, but the main part of it is that black hole, which is kind of holding everything together with its gravitational pull. Anyway, so you can see in these pictures what they kind of look like. So here is very similar to what the Milky Way would look like, a spiral galaxy. The elliptical galaxy is very roundish in shape, and then irregular, obviously, there's no like noticeable shape to it. Just a bunch of different kind of stars hanging around and not any shape or pattern. And a bunch of star systems as well, because galaxies are made up of many star systems, not necessarily just a couple stars, but a bunch of star systems hanging out together. Okay, so we live in the Milky Way, so this is kind of separate from the other stuff that we're talking about, just because this is our own personal galaxy here. Our solar system is located in the spiral galaxy called the Milky Way. You can see the center of the galaxy at night during the summer. This is kind of a picture of it right here. It's going to be like our center of the galaxy here, but it's pretty cool if you are able to see it on a clear night. Again, a lot of times, like the light pollution that we have in a city makes it difficult to see things like this, but if you're kind of in a place with no light pollution, during the summer it is easy to see that the center of our galaxy, the center of the Milky Way, so it's pretty cool. There's a picture in the book, too, that shows the side view and a top view of both of those things of our galaxy, which is pretty cool as well. You can kind of see where we're located and things like that. The book that I have online does not have that picture, but the book, your book, page 145, if you have it, shows a pretty cool picture of that. We've talked over and over again about how huge space is and how huge the universe is. So we talk a lot about it in terms of really big spaces and things like that, using really big numbers. So a lot of times that astronomers, when we use those very large numbers, we're going to use this thing called scientific notation. You'll learn more about that in math. That's kind of something we usually cover in math, but then kind of brings itself over to science when we talk in science as well. But the size of the observable universe is about 10 to the 10th light years, or 10 to the 26th meters. So that means a 10 followed by 26 zeros, or a 10 followed by 10 zeros, and light years. And light years, we know, is the distance that light travels in a year. So and this is just the observable universe. It's just stuff that we can see when we're looking outside. There's probably parts of the universe that we don't see because they're so far out there that they're not anywhere observable to us. The light isn't going to get here anytime soon. And we have, I think we've talked about this, but like the light that we look at night, when we look out and see the stars, it has been traveling for years to get to that point. So you're looking at light that has been traveling for years and years and years for us to be able to see at night. So it's not just light that's being produced that particular second that we're seeing. We're seeing light that's been traveling for years to get to the point where we can see it here on Earth. So it's pretty amazing to think about. And so this is the end of that section. In fact, I don't go any further into this chapter. I believe there's one more section, and I think it's on, let me see here. Oh yeah, it's about the expanding universe. If you have your book at home and want to look at that, you certainly can. I'm not going to do a lecture on it. It talks a little bit about the Big Bang Theory and things like that. I can post the reading. If anyone's interested, you can contact me. I'll post the reading material if you don't have your book at home, but I'm not going to cover it with the lecture. So this is actually the end of the book that we're going to be using. We'll start a new book then after that, which I can post reading material for you online for that, just because you probably don't have books for this, and I'm not sure how I get you the books. So anyway, there will be homework for this section. It will be posted on PowerSchool Learning, and as usual, you can either print it off, complete it, take a picture, send it to me. You can just complete it and send it to me, to put it on a separate sheet of paper and take a picture and send it to me, or you can hand any of that stuff in that you've printed off or taken a picture of on April 16, 17. All right, thanks. Enjoy.